I'm going to keep this process moving. So, Josh, I thought part of science was the importance of questioning past or present scientific ideas in order to make better and more accurate ones. So why are evolutionists and creationists so bothered by the other?
That was a long question. Yeah, I mean, with creationism, the issue is that the attitude towards science is not a testable attitude. It's not science in the conventional sense. It makes claims that sound sciencey but that aren't science, that you can't test in any meaningful way. If the idea is an omnipotent supernatural being created life, an omnipotent being can do anything, by definition. So anything that you find is compatible with that, but nothing that you find is going to distinguish between that and any other hypothesis, unless you have some way of limiting the power of that supernatural being, and then you're talking about something very different than the normal conception that the average person on the street has of God. You're talking about a much more limited being, not something that's omnipotent or something. And so it's not, on that level, it's not science. The other level on which it's not science is, again, this attitude towards testability. The claims that you see in Explore Evolution are the same claims that you saw in creation science textbooks. A lot of them are not that different than claims that you saw Brian making in the 20s. They've been disproven time and time again, and people keep bringing them up as if they were still valid, and they're not. And that's sort of, in that way, it's like astrology, that you can falsify astrology a bunch of different times. The fact that it is falsifiable and falsified doesn't make it science; it makes it wrong, and it doesn't belong in a science class for that reason. It's not science. It may have been some sort of plausible model of a science or proposal for a science 500 years ago, but it's not now. Same thing for phrenology. It may have been a science at one time, but it's not now.
Paul, what does mutation mean?
Well, in a broad sense, a mutation is a change in the genetic material which can be passed on from one generation of cells to the next. And so in cells in your body, when they divide, sometimes you have mutations that occur there. And if those mutations are involved in genes that regulate, say, cell division, then one of the possible consequences might be cancer. If the mutation occurs in cells that become sperm and egg, then they're passed on to the next generation of organisms. So mutation can include things like changes in a single base in a gene, let's say, or it can be a larger scale thing like a gross chromosomal rearrangement. For example, human chromosome 2 appears to be the result of a fusion of two chromosomes in our original ancestor. Okay, so mutations encompass a wide range of scales. I like to view evolution as a process, much in the same way that diffusion, the movement of a substance from a region of high concentration to a region of low concentration, is a process. But at the same time, we also have a theory that explains how diffusion, the process of diffusion, operates. In the same way, I view evolution not as a fact in the very narrow sense of the word, but as a process. And then the theory of evolution is our attempt to explain how that process operates.
Okay, fair enough.
I think it's also worth distinguishing. A lot of times when we talk about theory, if you know the X-Files or something, it's my theory about how the aliens from Roswell shot JFK is not a scientific theory, right? It's a different sort of thing. And a lot of times there's confusion because we use the terms differently in different contexts. And so a theory in science is an explanatory framework that incorporates facts, it incorporates hypotheses, it produces hypotheses. It's in many ways better than a fact because it explains facts. Facts on their own are just, this jumble of stuff that doesn't mean anything. The other thing that I was talking to a philosopher yesterday who made this point, that if you had Galileo looking at the moon through a telescope, he was applying optical theory to that, but he wasn't thinking of what he was doing as theory dependent in terms of optics. He was thinking of it in terms of, it was theory dependent in terms of gravity. So he was taking optics as a fact for that purpose and developing a theory of gravitation and of planetary motion. So how we, sort of the practical aspect of how scientists use theories as facts or as it varies depending on context. I don't know if that's helpful or not, but.
What?
I'll give you a different take.
Okay.
To me, a fact is like somebody commits a murder. That's a fact, but maybe nobody saw it. It's still a fact that the murder occurred, even if no one saw it. So a fact is something that could have been observed if someone had been there. It doesn't depend on anything other than just ordinary ability to observe if you happen to be there. And we find out what the facts are later by gathering evidence to figure out who did the murder, if there was a murder. But I may get it wrong. It's still a fact one way or the other that a murder happened or didn't. Well, it is a fact one way or another that it was common dissent. It's not a theory, it's a fact. Maybe I got it wrong and it wasn't a fact, but I think it's a fact that there is common dissent. Everybody descended from the same genetic background long ago. And if someone had been there, they could have watched it all the way along, cut notes, normal kinds of observation, no theory required, just watching.
Yeah, and sometimes we, what we think are facts are really, really just very, very strong inferences. I mean, here's an example I use with my students to explain the concept of homology, which says that if you have two structures that might have different functions, but they have a deep correspondence, then that we can infer they have a common evolutionary origin. And so I say to my students, suppose I give an essay test or an essay assignment, and I look at your essay, and I look at your essay, and I find that they're very much identical. Okay, what am I going to infer? What's the reasonable inference? And the students, sometimes they say, well, you're inferring that we cheated. And well, maybe not. But what I'm really inferring is that those essays have a common source. Okay, that's a real, real strong inference that can basically be treated as fact. I mean, you could try to argue that monkeys typing randomly and they just happen to come up with that, but that doesn't make a whole lot of sense. See what I'm trying to say? So many times what we think are as facts are really just very strong inferences.
And although, from David's point of view, there may be things that are absolutely factual, from the scientific perspective, we don't necessarily know if we have all the information. So we don't know whether this inference we're drawing is a fact or not. Yeah. Which is why scientists treat facts as still malleable and changeable, whereas in an absolute sense, well, there may be some absolute truth out there in terms of what happened and didn't happen, but when will we know that we have all the information we know? I mean, all the information there is. So we may never know what is fact and what isn't. Short of, well, even in our own experience, right? You can say, well, but I saw it happen. But how many people have been killed and, condemned to death in Texas or Kansas, for that matter, by eyewitness testimony that was wrong? So the brain is a filter of reality. And unfortunately, then that makes us fallible in that sense. But anyway, all right, I'm going to back to you guys here. All right, so David.
You're neat too.
Pardon?
You're neat too.
Yeah, you're fine. You got it.
As Paul mentioned in relation to evolution, typological thinking has its limitations. So what are the drawbacks of solely using typological thinking to talk about one's political opponents? Yeah, you know it.
Well, it's a good question. To me, it's hard for me to see an alternative. If you're going to be a political operative, then you just kind of automatically start thinking this way. You try to think of who are the guys that I can persuade one way, who are the guys I can persuade another way. You're always going to get it a bit wrong. It's always a model, it's not the truth. There's always the possibility of alienating people when they find out what your models are, because the models are often kind of nasty. There's lots of things wrong with it. You may start to believe your models. You may get stuck into thinking that there really are these kind of things and that's all there are. But they're just models. It's not the reality. So it's the general problem you have when you're dealing with models. You make mistakes.